So this lab session, so we are going to learn about Juniper routing. So that is RIP, OSPF, IBGP, EBGP. So I'm just doing fast forward to minimize the time, means the length of the video. So yeah, just I'm doing the basics connectivity to all the devices. So these are the 5 routers, the AMX series routers, and I have connected with VPCs. And this part is the reversion. Right side is the OSPF, and this is EBGP, and this is IBGP. So just mentioning the RIP, OSPF, and IBGP, EBGP. So coming to the subnets, so the RIP subnet is a 10.0.12./24, and the OSPF subnet is 10.0.13.0/24, and IBGP is 10.0.14.0/24. EBGP is 10.0.15.24. Okay, so basically I'm going to configure the root system authentication password. So as you are aware, whenever you are going to configure any of the thing in Juniper, so first initially we have to set the root password, then only it will be accept the other password to take effect. Other configuration to take effect. So fine, so I'm just setting the root system password in all the routers. Okay, so fine, so setting the root system password is like set system root authentication plain text password, and you just give the password and confirm the password also. So here the show compare will shows the configuration is done. Okay, so just execute those show compare before committing the changes. Okay, you can do show sorry commit check also. It will shows displays the error if any configuration error exists, so before committing the changes. Okay, so and next I'm going to configure the router host names. You can see. Okay, the next part, now I'm going to okay, so I'm just configuring the interface also. Okay, so as per our IP the subnets discussed earlier, so I'm using those subnets and I'm configuring those IP addresses in the router interfaces. Okay, so here I'm just setting the interface IP address. set interface gig 0 by 0 unit 0 family inet address 10.0.13.2 and the edge routers, and this is unrouter 4 where IBGP we configured. So that side the IP address is 14.2 and this is EBGP router. So there the 15.2 have been configured on their interface. Fine. So now we are jumping into our main configuration part. So that is RIP routing configurations. So I'm just configuring the same thing on the central router. Okay, so I'm just giving the IP address on those edge router connected interfaces. Okay, so here I using .1. Okay, so on router OSPF router I'm just checking some configuration, some interface. Okay, so fine. So now we are going to configure our RIP. So that is from R1 to R2. So show configuration. So you can see the interface IP address. Now I am doing the ping test for the routers, edge routers. Okay, I guess all the routers are reachable except the router RIP router. So I'm just troubleshooting that. Yes, so we miss the IP configuration on the RIP router. Yeah, I did that mistake. So that is I just mentioned gig GI. Okay, that's why I didn't ping that IP address. So I'm just deleting that GI interface. It should be GE 0 by 0 by 0. Now fine. So compare. So it's showing what I'm going to add and what I'm going to delete. Now the interface is pinging. Fine. Now we are going to RIP configuration and the Juniper routers. Right. So I'm in center router. So edit protocols RIP. So in that RIP we have to set the group name, that is RIP-G in caps letter, and we have to mention the neighbor. So the neighbor is our exit interface, I mean where the other end connected interface router. Okay, so that's here GI 0 by 0 0. So now that's fine. So the protocols RIP, group RIP-G, neighbor GI 0 by 0 by 0. Now we have to configure the same in our edge router, RIP edge router. So there edit protocols RIP, and and RIP. So set RIP group. That group name is RIP-G in capital letters, and neighbor, and our exit interface is GE 0/0/0. Set so yeah, so RIP protocol we have been set. Now I'm going to use one loopback interface on this router to advertise that loopback interface in the RIP routing table. So as our router is routed to, I'm using the loopback interface IP address as 2.2.2.2. Fine. So show compare. After that, commit. Now here we have to do some routing policies. Edit policy options, policy statement, RIP export. So set term TRM from the protocols, direct connected interfaces. I'm going to advertise in the RIP routing table, and then it should be accept. So show compare will give us what the commands we have been added. So as Cisco we are using do, so in Juniper we have to use run. So run show routes. Still the route is not learning. Yep. So yeah, so we miss the RIP export. I mean the policy of, is we didn't define in the routing RIP, means route protocol RIP protocol. So again we have to edit protocol RIP, and then set group name, export, and the name of the policy, that RIP export. That's it. Show compare and commit the changes. Okay. Still we are not getting that route. Okay, then we'll troubleshoot that issue. So here show okay, neighbor we defined, and export we done. The policy map, direct interface connected, we are advertising in the RIP table. Again you'll see show compare, nothing to do the commit. Okay, we'll go back to the router 1. Still we are not getting that route. Okay. Okay. We'll check in router 1. Maybe that the configuration we missed to commit. Okay. Yep. So there is no configuration. So we'll see. Show compare. So what are the still pending things here? So these are not yet saved. So let me commit. After that, again see show configuration. Yep. Now it's good to have back that configuration. Yep. So now we are getting that 2.2.2 from the router 1. Sorry, that router 2, that is a RIP edge router. Okay, so that's fine. So RIP part is now completed. Now I'll jump into OSPF configuration. Okay. Edit protocols OSPF. Set the area 000 and the interface, and the interface which is going to be part of OSPF routing table. So here the interface which is connecting to router 1. Okay. So now we have to set one loopback interface. Okay. Okay, so adding that interface is 0 by 0 by 0. That's fine. Now set interfaces loopback 0. In is 0, family inet address should be 3.3.3. So this is the loopback address of router 3, so which we are going to advertise in our OSPF database. Set protocol OSPF. Okay. Set area 000 interface loopback 0. So that is now we are advertising in OSPF routing table. So now commit the changes. Yep, so we done that part. Now I have to verify the routes whether. Yep, so guess we have to do in the same way in router 1, that is our central router. Okay, so you can see, okay, show route, still that 3.3.3 is not at land. Okay, so show SPF neighbors, so the neighbor stuck at two-way, it's not yet fully converged. So let's we troubleshoot further. Okay, so now you can see it again. Yeah, so we got that route, so let me ping that. Now it is pinging. It's good. So the OSPF part is also configured. Now we're going jumping into IBGP. So in router 1, that is our center router. So edit, before that we have to do set routing option, autonomous system number. So that is ACE number. So for router 1 we will select ACE number 100. Okay. Edit protocols, BGP, and set group name, neighbor. So neighbor would be our router 4. So 10.0.14.2, that router interface IP address, and then the type, the IBGP type is internal, and the local address is 10.0.14.1. That's it. So show compare. So it will now commit the changes. So we'll set one loopback interface in router 4, so that we can advertise that loopback IP address in IBGP table. Okay, so I'm setting 4.4.4 as it is router 4. edit protocols, BGP. So set group IBGP. So the neighbor with 10.0.14.1, and the type would be internal, and local address is 10.0.14.2. And that's it. So yes, we have to configure. Still, we have to configure the ACE number. So let's see. So set routing options. Autonomous system number would be 100 again, because we are going to configure IBGP. So should be the same ACE number. Now we have to do some same policies again, like RIP. So we have to define the policies. So I given the policy name as IBGP export. Set TRM, and from protocol direct. So directly connected interfaces, we are advertising in the IBGP table. Set TRM, then accept. So compile and commit the changes. Yeah, let's verify again. Yeah, all configuration seems to be there. Yeah, yes. So we have to advertise. Use that policy options, means policies uh, in the routing protocol. So set group IBGP export. We have to do it under edit protocol BGP. Yep. So we use that policies to advertise that direct connected interfaces in IBGP. Show compare. So nothing to commit the changes. Fine. So show run. Yeah. So we are getting 3.3.3 as well as 4.4.4 from the IBGP name. So it's pinging. That's good. Now IBGP part also completed. Let's move on to our EBGP. So tab. So edit protocols BGP. Set group name, neighbor 10.0.15.2. Set group name, type external. Set group. Oh, so I supposed to use EBGP as a group name. So there I did the mistake. So I'm just deleting the group names, whatever the configuration we did so far. set group name EBGP neighbor 10.0.15.2 set group name type so external BGP set group name peer is 200 and the local address is 10.0.15.1. That's it. So show compare. So this seems fine. Now tap commit the changes. I'll go to router 5 set interface loopback 0 unit 0 family inet address 5.5.5. So this is the loopback IP address setting in router 5. Now set the routing options. The autonomous system number, it will be 200. It's different than the router 1 to behave like the EBGP neighborship. Edit protocols BGP. Set group name neighbor 10.0.15.1 and set group name type external and set group name peer is 100 and set group name local address 10.0.15.2. So the EBGP configuration part is completed. So you can see, so compare. Okay, seems good. Exit and show compare again. Fine. So okay, commit the changes. Okay, so I'll go to the router 1. Oh, so policy options forgot. So edit policy options, policy statement, EBGP export, and set term TRM from the protocol, the direct set term TRM then accept. Top edit protocols BGP set group name export name of the policy EBGP export enter. Top show compare tip commit the changes. Now see show BGP summary. Yep, neighborship established. Okay, says number 100 is number 200 and the uptime packets out packets fine. So fine, so BGP summary again to see in the neighborship it's fine. So your route okay 5.5. so you can see ping 5.5. now it's pinging. That's great. Ensure route, so we have only route 2, so that is directly connected, and this is router 1 is the center router. There we are getting some RIP routes, OSPF routes, EBGP routes, IBGP routes. You can see the AS path is I only, whereas AS path is 200I. That means external IBGP. This seems to be good. Yeah, so inside the router, the router 1, we are learning all the routes. That's good. So now we have to use the policies, routing policies again, to redistribute the routes from one routing protocol into other routing protocols. So I am just creating the policies again to advertise the RIP routes into other routing protocols. So I just give the policy name as RIP to OSPF. Okay, so set term TRM from protocol RIP. That's okay. Enter. Exit. So show compare. Show compare again. So I want to remove. So I want to remove this policy. So I just want to do the rollback one level above, so that only the recent changes would erase. Now I will remove that policy RIP to SPF. I want to create the more granular name for the routing policy. Okay, so again edit routing options, policy statement, RIP to OSPF, IBGP and EBGP. So it is advertising to all the routing protocols. Set term TRM from protocol RIP. Set term TRM, then accept. Exit. Show compare. Okay, the policy seems good now. Okay, yeah, so we have to apply the policy to OSPF, EBGP, IBGP groups. Okay, edit protocols, OSPF, set export, and the export name of the policy. Edit protocol BGP, group name, set group name, export, and the policy name. Now set group name. Okay, set group name, EBGP, export the policy name. That's it. So we configured under all the routing protocols. Okay, so exporting in IBGP, exporting EBGP, exporting in OSPF. That's fine. So this is our policy, and comparing RIP only and then accepting. That's good. Commit the changes. router 2, the OSPF edge, you can see there is no route for the router 2, that means RIP edge router, and in IBGP also not there, in EBGP also not there. Okay, so let me commit the changes in router 1, that is the center router. Okay, so let's check again. Okay, still route is not learning by OSPF edge router. Yep, so now started learning. Okay, so we're getting router 2's loopback interfaces. Yep, so in router 5 also we are getting. Okay, router 3 and router 4. Yep, so now we are getting that the routes also in router 4. Yep, router 5 also. Okay, so we configured RIP routes advertised into OSPF, EBGP, IBGP. Okay, now our next move is to advertise our EBGP to IBGP and EBGP to RIP and EBGP to OSPF. So here, so EBGP to IBGP routes are learning by default. Now we are going to OSPF to RIP. Yeah. Let's get into the configuration part. Okay, so this is the RIP to OSPF IBGP EBGP policy name. Edit protocols. Edit policy. Policy statement. OSPF to all. Set. Term. TRM. From protocol direct and OSPF. Edit protocol. Edit policy options. Policy statement. OSPF to all. System TRM from protocol direct as well as OSPF. And then accept. Exit. Show. So you can see. Okay, the policy is there. Okay, so we have to add over here under EBGP, IBGP as well as her RIP. Edit protocols, RIP, set group, group name, export, and policy name OSPF to all. Exit. Show compare. Okay. fine. So policy statement, term, protocol, then I accept. Okay, let's commit this change. Yep. Before that, we have to advertise that into the other protocols. Edit protocols, BGP, set group name, IBGP, export OSPF to all, set group, EBGP, export OSPF to all. Sorry, so we mentioned the wrong group name. Yep, that's fine. You can see, yep, show compare. So there we have unnecessarily created one group name, that's okay. So we are just removing one policy name and editing again into with other policy names also. Export, okay, fine, exit. It's fine. So yeah, we have to remove the group name, delete. Okay, delete, set group name, delete group name, IEBGP, fine, again show, group name still there. Yes, I guess remote. Okay, commit the changes. Now go to the router 2. You can see there the OSPF route, means the interface is learning and loopback interface IP is learning, so you can ping that. So it's pinging from RIP edge router to OSPF edge router. Okay, that's great. Now you can move on to the router 4. There we can see the show route. Yeah, we are getting the OSPF loopback interface IP address. So 3.3.3 as is then IBGP. So we're getting as an I path only. It's pinging now. That's great. Now you can see in router. Okay, IBGP is still not learning. So okay, now start learning. So let me ping it. That's great. It's pinging. Yep. So that's great. Now we achieved the OSPF advertisements into the other routing protocols. Okay, that's good. Now this IBGP into RIP and OSPF is okay. So we'll jump into the configuration part again to advertise our IBGP route loopback interface into the RIP as well as OSPF. Okay, edit policy options, policy statement, BGP to all, BGP to all. Okay, set term TRM from protocol and BGP as well as direct. No, only BGP and direct. Enter. Now again then accept. That's great. Now exit, edit routing, edit protocols, RIP, and we have to advertise that IBGP route into RIP routing protocol. So okay, set group name, export IBGP to all. That's it. Exit. Edit protocol OSPF. Advertising into the OSPF. Okay, set area 00. No, it will not take there. You have to set export IBGP to all. That's it. Exit. Show compare. You can see here it is added one more export policy. That seems good. Okay, and also it is adding one more export policy. That's fine. Our policies okay. IBGP to all from BGP and direct connected interfaces. Then accept and commit the changes. That's good. Now let me show routes in the router 2, that is a RIP. I'm getting that IBGP routes and EBGP routes. Let me ping them. Yeah, IBGP interface pinging and EBGP also pinging, and can see in OSPF also learning all the routes. That's one. Let me ping them. Okay, so ping 4.4.4, ping 5.5.5. This seems good. So now where the route is learning RIP, IBGP, EBGP, OSPF, and from all the routers they are pinging to the all the loopback interfaces. So this seems we achieved our target. Yes, that's good. Okay, from router 5 to router 1, router 2, router 3, and router 4. That's great. That's great. So here we achieved our target. So we advertised our RIP to all the other routing protocols, from OSPF to all the other routing protocols. So all are converged and all are learning, all are pinging from one to other loopback interfaces. So yep, so we achieved our target. So yep, so happy. So it will, yeah, so Juniper, happy to learn these things. Thanks for your time. Yep, have a good day.